Hello students, in our previous videos we discussed about how to add integers and how to subtract integers. In this video we will discuss about how to add by properties of addition. How to add by properties of addition of integers. So first property is closure property of addition, which says if we have two integers, suppose one is 5 and another is suppose -2. When we add both the integers, that is 5 plus -2, then the value which we get, that is 5 plus -2, that is 3. So this 3 is also an integer. When we add two integers, then the value after adding which we get is also an integer. I hope all of you understood closure property. Our next property is commutative law of addition. Commutative law of addition says if we have two integers, suppose a and b, then a plus b, when we add a plus b is equal to b plus a. Both are equal in value. Just suppose when we add 5 plus -4 is equal to -4 plus 5. How? Let's check the value. 5 plus -4, and this is -4 plus 5. So this is 5 minus 4 is 1, and this one is minus plus minus, and minus plus minus, that means 5 minus 4 is 1, and the sign which we put is plus sign, because which number is greater? 5 is greater, and before 5 we have plus sign, so we have to put here plus sign, and here is nothing sign, means plus sign. So plus 1 and plus 1 both are equal. So when we have two integers a and b, then we can write a plus b is equal to b plus ai. I hope all of you understood the commutative law. Our next property is associative law of addition. Associative law of addition says if we have three integers a, b and c. In this case, when we add a plus b firstly, and then we add the value of this with c, is equal to a plus both when we add b plus c. For example, if we add 2 plus 5 and plus 3 is equal to 2 plus 5 plus 3. Look at here nicely. Here we add 2 and 5 firstly, and here we add 5 and 3 firstly, but both the values are equal. So solve this one. 2 plus 5, 7 plus 3, and here 2 plus, this is 5 plus 3, 8. So we have 10 here, and this one is also 10 here. So I hope all of you understood this associative law of addition. Firstly, we have to add a plus b here, and here we have to add b plus c firstly. And then a plus b we have to add with c, and here b plus c, the value b plus c, that means 5 plus 3, that is 8. That 8 should be added with 2. And this 7 is added to 3, but both the values is same. So I hope all of you understood associative law of addition. Our next property is existence of additive identity. Existence of additive identity. This property says that actually 0 is the additive identity for any integer. As all of you have to know, when we add, suppose we have an integer a and when we add this one with 0, or when we add 0 with any of the integer, then we have the value is only a. That means suppose we have minus 2 plus 0, or suppose we have 0 plus minus 2, then lastly we have both the value is minus 2 plus 0 is also minus 2, 0 plus minus 2 is also minus 2. One more example, 5 plus 0 is equal to 0 plus 5. If we add 0 from 5 and if we add 5 from 0, in both the cases the value is only 5. So this 0 is the additive identity of any of the integers, because when we add 0 with any of the integer, the value never gets changed. I hope all of you understood this existence of additive identity. Our next topic is properties of subtraction of integers. For subtraction also, first one is closure properties. Closure property. Closure property for subtraction and addition both are same. Both are same. That means when we subtract two integers, then the value of the integer is also an integer. Commutative law. For commutative law, a minus b, since we are using subtraction, so a minus b is not equal to b minus a. That means suppose 5 minus 2 is not equal to 2 minus 5, because 5 minus 2 is 3 and 2 minus 5 is minus 3. Both are not equal. And same as that, third one is associative law. This one also not follows. That means a plus b plus c is not equal to a plus b plus c. I hope all of you understood that in subtraction, closure properties is only matching with addition rule, and the commutative and associative law not follow the same property of addition.